You're listening to the Not Just Numbers podcast, a conversation with mathematicians on their work and their lives to get to know them and discuss common biases and misconceptions.
Hello everybody and welcome to the next episode of It's Not Just Numbers. Today we will talk about the differences between probability and statistics. And for this, as always, we have two guests. We have Gilles Bonnet and Grzegorczyk. So maybe our guests would like to introduce themselves. Marco, could you maybe explain to us what you do and what type of mathematics you're into, but in a way that it would be understandable for somebody who does not have a big mathematical background?
Yeah, thanks for inviting me and for having me today. My background is actually in statistics and I analyze data. So in many scientific fields, people collect data and there's need for analyzing the data. And that is when I come in.
Interesting. Gilles, can you tell a little bit about what you do?
Yeah, sure. So I'm doing stochastic geometry. That is something that is at the intersection between probability and geometry. So you think of anything that has some geometric flavor, points, position in space, because maybe this corresponds to antenna for your phones, and you don't know where they are exactly, so you think that they are at random position, and the people with their phone connected to those antenna, they are also at random location, and then you want to study this. So what is the typical distance from between you and the antenna, or how many users will be connected to an antenna? So, okay, here I'm using an analogy which is very practical matter, but I'm more on a very theoretical aspect of this kind of problems. Huh?
Thank you. Sounds very nice.
Can I get back 1 second to Marco, because I'm curious. Say you are working with data and analyze the data. Can I ask you what does it mean to analyze the data? Assume I know nothing about this, because I do know nothing about this. What would that mean?
Yeah, I would say in principle, data are usually collected because there is information in the data and you would like to extract the information from the data. And standard statistical methods often are not tailored for the data that have been collected. And so I try to develop new methods that get the most information out of the data. So I help people to get a better understanding of their field, to provide evidence for the hypothesis they have in mind.
Thanks. So given that we are talking about you two, I'm curious actually to hear, how did you get where you are now? So what was that made you interested in mathematics in the first place, or statistics? So let's start with Gilles. So how did you become a probabilist, and what is it that sparks your joy or your interest?
The fact that I became a probabilist came quite late, but I've almost always been interested deeply in mathematics. As far as I can remember, it was like I think I was in primary school and my older brother in the secondary school. And then, I don't know, he said something about Pythagoras theorem, and then I learned about it, and then I was happy to know something that the other kids would not know. And somehow that was making me special, that I had this little feeling. I don't know if this is the real reason, but as I remember it, this is the initial spark. And then I've always been very interested in mathematics, and I was receiving magazines about it, participating in some little competitions, but it was more like games. And I had the chance to have very interesting professors or teachers in schools who were doing some extra activities with games. And so it was always very playful for me. And it was not so much the mathematics we were doing at school, but all the other things around it. And I think, as I was already a bit saying earlier, my interest was also nourished by the fact that was making me a bit special. That was like my own thing. Huh? And then I was also not very interested in many other subjects, which was a bit silly from my side. And in France, so I'm French, in France, in the school system, you don't need to pass each course individually. You only need to have an average grade to pass to the next year. And then it becomes worse as the years evolve because those grades starts to be weighted. So if you choose to do more sciences at school, then you can have that mathematics weight 9 times what German course will weight, for example. So, so I was sitting in my German classes, not listening to anything, having grades close to the worst grade you can have, and on the other hand, doing a bit vaguely some efforts in mathematics, but because I liked it so much, then I could go to pass the years like this. And then at university, I really felt that I liked what was the content. I was not a very hard-working student. Maybe I should not say that because this will set a bad example for the student. But I was not going often to the lectures and so on. I was more one of the students who take the material and read it on its own, and it worked fine. I was not ambitious of having excellent grades, just learning the things, and it worked fine until a point where I realized, that's very bad. There are some subjects, some theories that I should know much better, and luckily I could catch up with this. That's the first years of university. Then, for some reasons, I became a teacher. In another life, I've been a teacher in school for 2 years.
Cool.
In high school. So I taught mathematics. And then I came back to academia. I did another master. And then I was looking for a PhD position. And so this master that I did after being a teacher, I was in Barcelona, in Spain, under the sun, next to the sea. It was very nice. I had tried to do a PhD there, to stay in this very nice environment, but there was no money. And so I started to open the search radius and to look a bit around. And I was more interested in mathematics in direction of algebra. But since I've always liked all mathematics, I just applied a bit randomly and being open to what opportunities will present itself. And I ended up in Germany, in a small city called Osnabrück. And then I became a probabilist randomly because the opportunity presented itself. But what was great in this is that it was not just probability, it was probability with a mix with geometry, which I've always liked geometry because something you can visualize. I've always liked with mathematics to think about it in a visual way. And this is how I became a probabilist.
That's quite a long story.
Yeah, sorry.
No, that's perfectly fine.
I gave too many details.
I was wondering, what made you decide to become a teacher and then after 2 years of teaching decide that you wanted to get into academia?
Okay, so first I really liked mathematics, and then being a teacher is some kind of a safe option, and the system, at least when I was in this system, encouraged you to get this plan B. So whatever happens, you can always go back to your plan B. And actually, with the French system, I'm still a teacher in France. Oh. I could next September go back and be a teacher because for some reasons I'm a civil servant there. I passed some competitive examination called CAPES and agrégation. And this gave me a job that I could keep, that I could have decided to stay in France for the rest of my life and be a teacher there. But then at some point, after 2 years, I asked if I could get leave. And they could have refused, depending on how I asked. But I had some personal reasons that I could for which I could motivate the leave. And they gave it to me, and then it became another reason because I was being a PhD. Then they say, okay, we can extend the leave. Then I eventually got a child, so now I have a leave until my son will be 12 years old. So I still have 7 years where I can keep this plan B, which I don't think I did, but yeah. That's how I became a teacher, because I was encouraged to take this, and I was also not sure if I want to be a teacher or if I want to do research. I mean, both aspects sounded very interesting to me. But then when I was a teacher, so first of all, it's not easy to be a teacher in school, so I will not pretend that this was the smoothest years of my life, those 2 years as a teacher. There were some good aspects and some more challenging ones. But then there were also some reasons from the side of the heart that I wanted to go to Spain. So I combined everything by like going back to academia and going to Barcelona by going back to academia. That's it. And then I never consider turning back. As long as I had opportunity to stay in academia, I stayed there.
Yeah.
And now I've got this fantastic job in Groningen, so very happy.
Yeah. Thank you.
One thing that I really liked of all episodes so far is that everybody has such a different story, right? Some of them are super linear, some of them are jumping all over the place, some in between. So it's very interesting to hear what variety of experience we are bringing on the table. So Marco, we are curious now about what was your path to statistics and to becoming a statistician?
Yeah, actually, it started at high school when I struggled a little bit in general with most subjects, but never had problems with mathematics. And so my original idea was to study mathematics. And just as a kind of counterattack, my hate subject was actually French, which was my first foreign language, and I struggled a lot with French. But after all, I made it then to university, where I first considered studying mathematics or becoming a mathematics teacher even. And on a rather short note, I decided for statistics, having a little bit in mind that maybe statistics is rather broad and could bring me later into different fields, where I had this feeling that mathematics is very narrow, very theoretical, and has not so many connections with other subjects. So it was maybe my point of view at that point of time. And then I decided to study statistics rather than mathematics, and never really regretted this. And that was actually in Dortmund in Germany.
Oh. Did you always know that you wanted to pursue a career in academia, or did that came later on?
For me, it was more or less clear if a PhD position would, so to speak, be offered to me, if there would be the opportunity, I would definitely take it. But it was not clear to me that it would be offered, that it would be there. And so I also considered alternatives to this path.
Right, yeah.
And since then it was linear, like you look for postdocs, and then you got in Groningen directly, or
actually I did a postdoc in Edinburgh in Scotland, and that came out of my PhD project. So there was some collaboration with someone, Dirk Kusmeyer in Edinburgh, and he finally brought me there and became my postdoc supervisor. And then I returned to Germany, and thereafter ended up in Groningen, which was like 10 years ago.
Yeah, thank you for sharing these stories with us. I'm also interested to hear in your careers, what have been your main drives and your main motivations to do the research that you do? Marco, maybe we can start with you.
Yeah, actually, it started with my PhD project, which was on Bayesian networks, and I really liked the topic. And then, back then, systems biology was a very big field of research with lots of money being available with many positions. And because I especially liked these Bayesian networks, I stayed into systems biology and was employed finally from the School of Biology in Edinburgh. And then after a while, you try to stay in this area. And I liked networks, learning dependencies between interacting variables. And that made finally my research line.
Nice, thank you. Gilles, what would you say has been a big motivator for you in your research?
As I was saying, I'm sort of opportunist. I ended up where I am because I took the opportunities that came along. And I ended up in the field of random geometry randomly. But there is this this fact that I've always liked geometry, and that felt like a good match. And so what I was saying is like for maybe the subject, but in general, mathematics and research in mathematics, I really enjoy the little challenging aspect, that you have a problem and you don't necessarily know what can be said about it. You explore this phase of exploration. You try things, then sometimes you get to a solution, and then it's big satisfactions. You understand things better. These are the kind of things that drives me, I would say, with the research. Yeah,
I do recognize that a little bit, even though I'm just a student. But that's funny. Yeah,
and it's also nice that it builds up on what you said, that you didn't really care much about the subject because you liked kind of the variety of mathematics that was coming to you, right? If I understood correctly.
Yeah, that's correct. Yeah.
So it's really about the experience more than the subjects itself.
Yes, I think so. I mean, I always like this geometric aspect, but I guess I could have, if other opportunities would have presented themselves, I could have ended up in a very different area. Yeah.
And Marco, is the feeling similar when you work on statistics? Like, is this same experience of having a problem that you don't understand how to solve, and then finding your way through, sometimes through obscure path and sometimes getting the right path until you understand it and you crack it open, if you wish?
So I would say a certain similarity is surely that I'm very opportunity driven, because there are always trends where people collect different kinds of data, where, let's say, search-free money is made available for people to collect data in particular areas. And of course, these data need to be analyzed. And that is, of course, then very attractive for me to get into this field and to develop the needed models. And in this way, I can hardly justify my own research line, because I always depend on data, and I myself do not collect any data. So I'm always dependent, if I want to do state-of-the-art research, to collaborate with people from other scientific disciplines.
Do people from other disciplines also approach you, that they have certain data that they want to have analyzed, or does it not really work that way?
So my experience is that they typically have also expertise in statistics, and then they can apply the standard models to the data, and often they're not satisfied with the results. And they see there might be more information in the data, and that is then when I come in and they ask me, can you not maybe come up with a better model which also takes this and this into account and extracts more information from the data?
Yeah.
So they realize themselves what we have collected the data does not match the standard requirements of the off-the-shelf method.
Yeah.
And then you are not just in the analysis, but also in the modeling side of it. So figuring out what is the right way of manipulating or rethinking about this data to get this extra information out.
Yes, exactly. So my research is actually methodological. That means I develop models as well as inference methods for the models.
I see, I understand. Thanks. Now, before we move more into this dichotomy probability statistics, I'm really looking forward because I've been confused about the difference so many times. I'm curious to what you do outside mathematics and outside statistics. Gilles?
Now I'm a father, so I have a wife and a son, so a big part of my life is family. So a big part of my life is my family. And then... So in the last 2 years, another big part have become a passion for running. Running a lot, long distances. And so maybe a funny story here is this morning I came running to work. I got up, I prepared myself. At 7 I left the door, I ran. I live in Grijgsheld, so I passed through Noordhoorn. And I was listening to a podcast. So in those long runs, I like to listen to podcasts sometimes. I was listening. Guess which podcast I was listening to? So that was your podcasts, and nice. And I was listening to the podcast with Jaap and Oliver. And when I arrive in Nordhorn, I see someone walking with his dog, and that is Jaap. So that was a bit the funny story of this morning. So yeah, that's the two things that I have these days: family and running, I suppose.
Yeah. Are you also training for a long distance, like marathon or I don't know, something like that?
So in 6 weeks, I will participate in a race that is in Vamberg. Do you
in
know?
Drenthe.
In Drenthe, yeah. So I've never been there, but there is a hill which is 4,800 centimeters high, I think.
Really big in the Netherlands.
And the race has a funny format. It's a loop that goes a bit up and down around this hill. So when you do one loop, it's 100 meters of elevation. And you try to do as many loops as you can within a certain amount of time. And you can register for 4 hours, 8 hours, 12 hours. And I registered with some friends for the 8 hours format.
Oh, that's impressive.
And we will see how it goes. I have no idea. Yeah, they have no idea about that. And this is actually not it's a race, but the competition is just like against myself, so to say, to see what I can do. And it's actually a training, because it's a training for another race, which is in Groningen in July, called Kardinge Bultra. So the Kardinge Bult, and it starts on the Saturday 20th of July at 4 p.m. And it's also a loop. You do 6.7 kilometers. And if you finish within 1 hour, you earn the right to go for another loop at the beginning of the next hour. And so on and so forth, up to potentially 24 hours. So it's so you don't need to run fast at all, because it's not a long distance for the 1 hour format. But it's like, how do you manage your energy, your body, your hydration, what you eat? Your psychological aspects are also challenging. How do you react when you get very tired, or if there is a little problem that comes, that you start to have a blister, and you have time to fix it maybe, but yeah. So yeah, it's I'm really fascinated by this kind of challenges, because it's so much unknown. Yeah, it's also you're exploring and discovering yourself, but also an environment with other people like-minded who are ready to do this kind of challenges that can be a bit surprising.
Yeah.
Oh, nice.
A lot of respect.
Yeah.
Well,
and good luck.
Yeah.
Let's see. So far, I only registered. I tried last year, and I did half of it. So
that's not bad.
That's already 12 rounds, right? That's
correct. Yeah. And that was very funny, because I had some colleagues that came to run with me for one loop, and there was Roland came from 1 a.m. to 2 a.m. So he had something in the evening in the city, and then after that he came to me, and he ran one loop, and I was really, really destroyed when we ran together. But after that I still managed to do 2 more loops, and then that was the end.
Impressive. Yeah. So you want to reach that goal this year, or you want to go for 13 loops, or?
I want to go as far as I can, and to end up satisfied. And if ending up satisfied means that I push myself, that I don't stop at the first trouble. So yeah, last year during the race I was a bit disappointed, because I felt my body was reacting worse than I had anticipated, and so I was a bit annoyed by this. But then what really gave me satisfaction is those 2 last loops, where I thought, when I reached at the end of the 10th loop, I thought, okay, now I'm gonna stop. I will stop. And then someone says, come on, Gilles, you can just try to go 100 meters and you turn back afterwards. And then I went and I did another loop. And then again, I ended up, so it was better, and then it was worse. And then I stopped. Okay, I will stop. And same story. And then so to do these 2 extra ones, and then I was not within the 1 hour. I took more than 1 hour for the last loop, so I was disqualified. But this is the part that gave me satisfaction. So I'm looking a bit for this to see that I can push further. Yeah. That's,
yeah, sounds like a nice goal, I think. Marco, what do you do outside of being a mathematician?
Yeah, actually, I also like to do some sports, but after the elaborations of Jill, I feel I cannot be very proud of running 10 kilometers every weekend.
I think that's impressive.
Wow, that's impressive.
Yeah.
For me personally, it is impressive, but after Jill's elaborations, I don't want to highlight it anymore that much. But in addition, I also go to the gym on a regular basis. And I realize at least the more often I go to the gym, the slower I run. And the better I run, the more strength I lose at the gym. So it's always just shifting back and forth. And also, I like a lot going to festivals and concerts. And I like heavy metal music.
Oh, nice. We should talk about music.
Maybe in another episode on music. Can extend the spectrum.
Do you go to festival around here only, or also bigger festival outside Groningen or the north of the Netherlands?
Actually often in Germany. So most of the time in Germany, sometimes also in the Netherlands. But then I'm rather flexible where to go to.
Very nice. So I can see we are about halfway through the podcast. So I would say that we can start steering a bit the attention from your personal stories to still your personal stories, but more to the
serious business.
Yeah. The original title we had for this episode was Probabilities versus Statistics, an epic rap battle. So I'm not going to ask you to rap your way through this unless you really want to. But we were discussing what are the common stereotypes and confusion that people have. And one that is often coming to mind once you take out the lone mathematician and the lone genius is probability and statistics are confusing, counterintuitive, and the same thing. So I would start from that. And in fact, I would start with the question I had for you, Marco, at the beginning. You said I was trained as a statistician. You really pointed it out immediately. And I'm curious, do you consider statistics parts of mathematics? Do you consider statistics related to mathematics, or do you think they are different things? I'm actually genuinely curious about this.
I would say, indeed, it's a discipline of mathematics. Originally, it belonged to mathematics, but after a while, it became an own independent discipline, like computer science, which made the same experience, traditionally belonged to mathematics, but became so big that it was considered an independent discipline.
And now I have a slightly more perhaps harder question that we need to try and answer in a way that doesn't require people to know mathematics. But so how would you define statistics? And how would you say that statistics is different from probability? And I'm going to ask later the same question also to Gilles.
Yeah, can I elaborate a little bit on this?
Yes, of course.
So actually it came to my mind, and I use this example in some of my lectures. When I go back to my childhood and try to remember, then I remember 2 things related to board games. And one of them is, often you need maybe to roll a 6 with a die to get started into the game. And when you don't get a 6 for a very long time, you might get the feeling that the probability for a 6 increases with time. So it feels like it's overdue, as if the die would be negatively loaded and must sooner or later produce a 6. And I would say this consideration is a probability theory consideration. You assume the probability for rolling a 6 is 1/6, and you feel something strange is going on. You produce now data which are rather unlikely. On the other hand, I remember if you have an opponent in a game, and the opponent produces many, many 6s, much too many than you would expect, then you get the feeling that your opponent is maybe using a biased die, and you might want to switch dice. And actually, I would say that is a little bit of statistics, because you factually observe data, you observe some unusual events, and you might want to draw conclusions about the probability of rolling a 6 with this other die. So you doubt that the parameter is 1/6. You observe data, which give you information about the parameter, and you then try to estimate what the true parameter is.
You would say it's the die or the person? I'm just thinking now when we were playing role-playing games and we have friends that would just usually roll once, whatever dice you give them, and others that would usually roll 6, whatever dice you give them. And you always say, oh, now you wasted a 6 when you toss a dice when you don't need it, right? And you get 1. So in statistics, when you look at this and these things, do you have a specific variable in mind, or you have to look also at the context around it?
In the end, you start with data. So it's data have been collected, and that might be an Excel sheet. And then you develop a model around it. So you model factually the dependencies between the variables that have been measured. And in this way, you try to find what kind of dependencies are really there and which ones are maybe not there. Because there might be also pseudo dependencies, just some pseudo correlations. And in probability theory, from my perspective, you would typically start that you have a given stochastic model, and then you study what kind of data, what kind of realizations would it produce? What kind of patterns?
So the other way around.
Exactly. Yeah. I would really say probability theory and statistics are complementary to each other.
Gilles?
Yeah, it's exactly that. I think if we continue with this analogy, I think the probabilist will make a model for the game and say, okay, if we assume that the die is fair, then and we do this and this, then in average this will happen, or with probability greater than 99%, we will have this or that. If we play many games, have a high degrees of certainty that so many games will be successful with that strategy, and with this strategy, some other outcome. So, you build a model, and then you try to draw some conclusion of this model without actually doing any experiments or looking at any actual data.
Can we maybe say that we have a love-hate relationship? Where we would say maybe on the surface you might have prejudices, where you say maybe someone from probability theory would say statistics is just analyzing data, just programming a little bit, while someone from statistics might say probability theory is useless. And deep inside we know we need each other. Probability theory is providing the framework, the mathematical framework for statistics. On the other hand, probability theory might need statistics sometimes to motivate, to justify certain approaches that they have long-term applications. So I would really speak of a love-hate relationship if we were a couple.
This actually resonates with what I remember about this from my studies. Like, it's a bit what we were saying with applied mathematics and general mathematics, that the moment you belong to a group, then somehow you start defending your group against the other. But then when we look at the mathematicians that are doing more theoretical generalist math or more applied maths, then you find that there's like a continuum of tonalities, people that are doing a bit of applied, a bit of generalistic, and very often they need each other. It's not black and white situation. And also there is a perceived love-hate relationship between the two, but then when you're working on that, you realize that this was just an artifact probably of belonging to different groups. So it feels like the similar thing here between probability and statistics, and also what I remember from my university times. You have given already a pretty interesting analogy to try and understand what is going on. But let me push it a bit more. So I know that there are many instances in which you see some data that reflect your ideas or that doesn't reflect your ideas, and then you or the person that disagree with you will come up saying, yeah, but this is just playing with numbers. If you have a statistics or if you have data, you can let the data tell whatever you want. And I'm curious to hear from you, what do you think about this? So Marco, what do you think?
So in principle, I agree that you can easily misinterpret data, but I would say if you do a proper statistical analysis of data, then you should always end up with at least comparable results. So it's of course a kind of wrong analysis that leads to wrong conclusions. But I would say what you originally said, if you really do serious statistics, you should not come up with every result you like.
How hard is to understand if you have done a serious enough analysis, or if what you're reading is done properly? Like, I'm not a statistician, so I would probably not be able to gauge what is being said. I don't know what is a p-value or these things that you hear when you read journal, newspapers, article about statistical data, for example.
Indeed, there might be a certain risk that in some fields outside mathematics, statistics, that people sometimes apply standard procedures and might struggle a little bit with the interpretation and so interpret it in a wrong way. So there's certainly a kind of risk that wrong conclusions are drawn. But I would say if you report properly what was done, then at least a statistician would see that the assumptions that have been made have not been met and that the results are not trustworthy.
So at least for the expert, this is questionable. Yeah. Gilles, as a probabilist, this is something where you have an opinion about, or this is not related to what you do? What do you think?
There are some paradoxes which can be explained by computing some conditional probability that's that I am ill given that the medical test is positive or negative, and sometimes the answer is counterintuitive because I don't know, maybe you have a medical test that is designed to be very accurate in case you are ill, and will most certainly tell you that you are ill if you are ill, but if you are not ill, it might still be positive and be a bit alarming. But then this is not a big deal apart from the psychological effect, because then you will run more tests and you will see that actually that was wrong. But it's not easy it's counterintuitive to think like, okay, if the test is very reliable in one situation, that does not necessarily mean that it is reliable in the situation where you are healthy. But what matters is that if you are ill, you really get to know it.
Can I ask, if you're researching in this field and you have a certain intuition towards data or towards a result that you're expecting, how do you manage your own intuition that you don't get the conclusion that you think you would get, and then be like, oh, this is probably the right conclusion? Because that would seem something, if you understand what I mean.
Well, the example I was giving is far from my research. It's a basic example with that you see in first year probability course with conditional probabilities, but. So I don't know how to answer your question.
What I mean, for instance, is that if you, if Marco has a lot of data and a certain result comes out of it, then you stay critical of that result, whether there is other instances at play in the data that might influence the result that you found, and that it does not directly follow from the data, but because of, I don't know, people who are overweight live longer, but people who are overweight live in countries where there's a good healthcare system, for instance. So that data does not correspond with what you find in that way. Yeah, Marco, do you maybe...
So actually, in a recent bachelor project, we found that if you drink a lot of alcohol and if you smoke, you live longer.
Yeah.
And it was actually worldwide data that we found if you drink a lot of alcohol and if you smoke cigarettes, then you're most likely to come from a rich country where the health system is better, and that potentially prolongs your life relative to some very poor countries where people tend not to drink and not to smoke.
So how do you stay alert on those kind of casualities?
One should be aware that you typically only study correlations from data, and you do not make any claims about causalities in the first instance.
Right.
So you need additional information to make causal conclusions.
Yeah, being very cautious.
May I add something to the example that Gilles said earlier? It is actually an application of Bayes' theorem, and this particular example is often used as an argument against screening tests. If you would say you have a very rare disease in a population, and you would have a test which produces with 90% probability a true result, but only a minority of people is really ill, then you would practically, let's say, all ill people would be tested positive in a correct way, while from the not ill persons, you would potentially have 10% which are wrongly classified as ill, and those altogether are much more than the small minority of ill people. And this way, if you have a positive test, you are more likely to belong to this large group of people that have been wrongly tested positive. And I agree, it's from a probability course. It's a typical application of Bayes' theorem, which then later on also plays a very important role in Bayesian statistics. And I'm in this school of Bayesian statistics.
Yeah, this is really going into this counterintuitive. The real issue there is that, like, when you are, say, tested, but in many cases there is a psychological aspect that is very hard to ignore, right? Even in what you were saying, correlation is not causation. That's very hard to step out of your own experience and say, the fact that I've seen this happening doesn't mean that these two things are actually linked in a causal way. One implies the other. Just because I saw it here. So
I think there's a prominent example from Sweden, which was from the last century, where actually it was observed that there's a large correlation between the number of newborn babies and the numbers of storks sighted, where people might conclude that maybe the stork brings the babies. And people wondered, where does this correlation really comes from? And then if you really go into more detail, you realize it's depending on the environment. There are areas that are very industrial, and in these industrial areas, people are working hard, have less babies, but also the stork doesn't really feel very comfortable in an industrial area. While other areas are rural, where families are typically larger with more babies, and then you have more storks in these areas because there is no industry. And that was really the explanation for it. Both are subject to the same trend. There's an unobservable or hidden variable, which is the causal effect on both. Or maybe here in the Netherlands, I think it's even the other way around. If people get a baby, then they typically put a stork into the window. And so I would say maybe the baby brings the stork.
Continuing a little bit on intuitiveness, Marco, if I can come back to the dice that you threw when you were a little kid and it was not 6 all the time, does it then mean that the next time that you throw it, that you will probably be more likely to throw a 6, or does it not work that way?
Yeah, good that you raised this point again. So actually, I think I gave not really an explanation for this. Indeed, my feeling was wrong. So actually, if you haven't rolled a 6 for a long while, the probability for a 6 does not increase. And I would say some people who think along these lines misinterpret the law of the large numbers, which would tell you the relative frequency of 6s indeed should converge to 1/6. But that doesn't mean that the expected number of 6s, which is the number of trials times 1/6, that this should also be approached by the total number of 6s you roll. So there the variance will get larger and larger, will increase with n, but the relative frequency will decrease in n.
Yeah.
And I think that is very hard to visualize without a board. But yeah, I get the point. So you're saying that if I keep not getting 6s, I would probably have to toss my dice some millions of billions of times before I start seeing this getting somewhere close to 1/6 of the time I get 6, if not even more.
So if you play for a very long time at a gambling machine, and this gambling machine lets you win in 30% of the cases, then if you play for long enough, you will indeed win around in 30% of the cases. But that doesn't mean that if you play 1,000 times, that you win 300 times. There will be a lot of variance around these 300. So it could easily be that you only win 200 times. That means having lost for a long while does not really increase the probability that you will win in the future. It's also independent. It's, of course, independent trials you perform. So there's no information of the earlier outcomes on the new trial.
Everything is really independent. As I remember this from the assumptions we always made when we were studying probabilities. This is what you do in courses, Gilles?
Yeah, everything is independent.
The IID.
IID indeed.
But does it mean that we only know how to predict or understand things when they are independent, or the theory actually goes further than that?
No, this is an assumption that makes a lot of things much more simple to compute. But of course, you can consider settings where you have events that depends on each other, and then you have to handle this dependency. And so, how do you do this? Then this is like the kind of questions you might be interested. But first, you need to understand how to deal with the simple situation, and then you make it more complicated by adding dependencies and so on.
But all the few paradoxes we discussed so far are happening when things are independent or they require this independence. I think like this thing with the law of large number you were saying, this is really using independence of each of the toss of the dice.
Yeah.
And the one about bias theorem with the diseases, that's instead with dependence, or it's also about independent event?
I mean, when we're talking about this example, we are just talking at doing one experiment. But if you talk about dependencies, you need to talk about dependencies between different events, different experiments. Huh? So I don't know if you will do the test for the entire population in a village, and then maybe the results for all the individuals, they will not be independent of each other because they are close to each other. So if one is ill, there is a good chance that the neighbor is ill as well, or depending on what you are looking at.
For example, if you wanted to investigate how many of our students are cycling to university, you might not want to recruit students only from one lecture, but you might want to randomly sample them from all lectures so that they are independent of each other. Because it might happen that mathematics students are more likely to cycle to university than applied mathematics students. And so you would either then, if you go to one lecture, only recruit applied mathematics or only recruit mathematics. Yeah. And so your sample would not really be independent anymore.
I see. So to make it independent, you want to reach as a wider and diverse audience as possible.
Yes, it should be representative for the whole population, and there should not be any pattern between why you selected those.
How do you know when a sample is independent enough? So, for instance, when we have the general elections at 9 o'clock in the evening, they give like the exit polls, and they're very accurate. It surprises me. Yeah, in the Netherlands, sorry. So in the Netherlands, we get the exit polls, and it differs maybe like 2 seats, which is like, not that much. But how do those people know when they take the data samples that the people that they ask, oh, who did you vote for? So it's a good representation of the Netherlands in this case.
So actually, I was often confronted in my life with this claim, how can it be that you only collect like 1% of the votes and you can already make a prediction what the outcome will be? But I always thought like if you have like 1 million voters and you ask 1% of them, then you actually have already a rather large sample size and should very accurately be able to predict what the outcome will be. Let's imagine you have an urn with 1 million balls inside. Yeah. 300,000 are maybe red, 700,000 are green. How many do you have to draw till you know that there are 30% red ones in the urn? Would you really need to count them all? Or wouldn't it be sufficient to say you take 10,000 out, and among them you would maybe have like 3,000, around 3,000 red ones? And this gives you already a rather accurate idea that the total number will be, so 30% of 1 million, 300,000.
Yeah.
But indeed, it's a bit challenging how this 1% is representative and not biased in one way or another, because maybe the 1% is all the places where the poll station closes early, and maybe those places are small villages, and then they are not representative of the population. So I don't know how they do to counter such effects. I think in the old time, in France, at least for these polls, they were doing the method of the phone book. They just pick a random number. Yeah? And then this is really, there is, like everybody was in the phone book. They were, and you could kind of, it was almost like the whole population, and you really pick people at random. But then you see, you have a bias of people who pick up the phone and not pick up the phone. So... yeah, I think then there are methods of quotas, maybe, like where you say, okay, in the population, there is so many people who have this age, that age, this kind of profession, and then you try to artificially take a sample that matches these proportions or correct, and then you correct your sample so that it matches these proportions. But this is, right now, this is really not my research. It's just like as any of other people being a bit interested. And so I don't know. This will be more statistician expertise.
So I think we were now speaking about two different things. So I was actually referring about all votes are in and you want to count a certain fraction to predict what the outcome is. What you're referring to, you want to make a prediction how people will vote at the forthcoming vote. And there typically, there's a lot of theory about this. You would really stratify the whole population. So you would somehow know in this city, typically the outcome is in favor of this party, while in another big city, the outcome is in favor of the other big party. And now, depending on the size of the cities, you would take sample sizes that represent the size of the population in the city. And in this way, you can more accurately predict what really the outcome will be. So it's a little bit like you said, in villages, maybe people go for one particular party, and maybe 10% of the population are living in a village. So in your sample you take, you try to include only 10% from the villages, because you know they have something in common. And you try to recruit 90% of other people, which are from the big cities, because you know there typically the outcome is in favor of another party.
Yeah. So then you select people based on, or you select votes based on where people live.
And maybe based on earlier elections.
Yeah.
So where it's already known what kind of trends you typically have in your population.
It was very interesting. It reminded me, I know it's nothing to do with that, but I had read this article some years ago about, I think it was about visualization, and they were showing that if you take point uniformly on a plane, so you just uniformly put down points on a plane, it looks like a gray thing. But then if you take this and you map it onto a sphere, that's no longer uniform on the sphere. In the sphere, they would cluster in some part of the sphere because of the way the plane is deformed into the sphere. And so you would have to do some, you would have to take a different approach that takes into account the geometry of the sphere if you wanted to have an actual uniform distribution of points on the sphere. And so the probability distribution between the two and the way you pick the point was different. I know these are two different problems, but somehow picking people depending on the age and the cities and the densities of the cities reminded me of this example between the plane and the sphere, that you were picking point at random, but to make it look uniform, you had to do it differently.
Yeah, these are different measures. Different, the uniform measure or non-uniform measure.
So another thing that comes up when talking about statistics and probability, I'm still mixing up the two. Perhaps I should ask you to define statistics and probability once more. But I think this is also because we are somehow, unless we study it properly, we grew up with this confusion between the two. And also because, as you said, they are like complementary to each other. So they really both play an important role when you're looking at uncertainty and understanding uncertainty or getting patterns, which is something that we tend to do a lot. But going back to what I wanted to say, something that now is popping up very often when you talk about probability and statistics is AI, because we have seen many things that AI is getting better and better at doing nowadays, but very often you also hear that no matter how good the models that we are playing with, say ChatGPT, Gemini, whatever you are playing with, no matter how good they are still statistical parrots, in the sense that, like parrots, they are repeating whatever they learn from the data that they have given. So they have the same biases of the data, they have sometimes the same kind of article they've been presented with in the training. So what you're doing, you're just repeating in some probabilistic, random statistical way the training data that you have given to it. And the point is that the training data is so big that it's unlikely that you see the same thing multiple times, but still, this doesn't remove the fact that they are not thinking, they're just spitting out somehow memorized data or memorized structure in the data. And I was curious, I'm no expert, again, in probability or statistics, so I can believe or not believe this, but it's not an informed opinion. I can understand a bit the linear algebra that lies behind it, but that's where my understanding ends. So I'm curious what you think about it.
Yeah. So I'm also not an expert at all. But like, are we not also some kind of parrots? We have also been ingesting a lot of data since the day we are born, or even before. Like every seconds we have millions of information growing through our visual cortex, then and we hear and we read, and then we repeat stuff that we have heard. Also, when we do mathematics, of course, we like the idea of the eureka moment where we have a new idea, but is any of what we discover new, or is it just that we reassemble things we have learned before, consciously or not consciously? So this question is, I find it fascinating. I don't know, really. So yeah, I'm no expert. I also don't really know what can be said about it.
So I would not agree that AI is a parrot of statistics. I would more think of it as the dark side of statistics. So it's black magic and the forbidden things of statistics they put into one discipline. But of course, I'm just joking now. So I have a very high opinion on AI, and I would say indeed they build on statistical models and tend to push them to the limit. So actually, they feed the statistical models with unbelievable amounts of data and push them to the limit. And this way, they reach astonishing results. And of course, this way they build onto statistics, but it's indeed with completely new features. And I would say AI and statistics are surely related. And the real big difference is that AI typically builds on huge data sets, while traditionally statisticians are trained to live with very small sample sizes, having in mind that maybe a lab experiment is very expensive and can only be performed a few times. And so you have to live with the small sample size. And how can you get most of the information out of a small data set? And in AI, it's more the other way around. How can you filter out the relevant information out of a huge data set to feed your model?
I see. That's very interesting. Yeah.
So I do not know a lot about AI, but does it then feel like they more brute force their results? So they just give it a lot of data and just see what rolls out of it? Or do I misunderstand here?
I think there's surely more computational power included. Yeah. And also there's maybe a little bit of a concern originally raised that they just apply it without having a mathematical underpinning. But these days, many mathematicians are also joining AI and providing the underpinning that is needed to be really on the safe side and to say what you do will really, in the end, produce reliable results. So it's a little bit like maybe in probability theory and statistics, probability theory is pushing forward and has already underpinning that is not needed yet, but will be needed in the near future maybe, or in the far future, while in AI it's a little bit the other way around. They already apply things without having the underpinning, and the underpinning comes later. So maybe probability theory should team up with AI.
Gilles, do you agree that there's room for probability theory in AI?
I think there are some probabilists who have started to study some neural network models and establish some theoretical results. But how far are they from the real applications? This I don't know. Yeah. I have the impression that there is a huge gap between the theory and how far the applications are going at the moment. Like the theory seems to be very on the probabilistic side, at least, very new and with limited result compared to the extent of the application.
Gilles, would you then agree to what I said, that maybe in probability theory and statistics, probability theory is a little bit ahead, and maybe some methodology you have invented is maybe not relevant for statistics, for data analysis yet, but might be in the future, while in AI it's a little bit the other way around. They apply already models and still need this underpinning coming a little bit later, but being provided these days by mathematicians.
Yeah, maybe we can say it this way.
I hope we don't make enemies today.
I don't think so. I mean, we are talking about our opinions, right? And everybody understands that we are not experts. But
But we have an AI department.
yeah, I know. But we in fact, at some point, we would like to talk to them as well in the next season. So maybe that will be a good link with that episode, starting from our discussion here. But I really like what we said. First of all, I never thought about this relation between statistic probability and AI and the way they are positioning themselves and they are related. So that's nice. And on the other hand, I also can resonate with what you were saying, Gilles, that we are in some sense also statistical parrots. And that's where my tension lies, because on the one hand, if I ask mathematical questions to ChatGPT, I can say that it doesn't reason. It's very easy to get it to say that 9 is a prime number. And then you say, but it's 3 times 3. And then they say, yeah, no, it's 3 plus 3 times 3 plus 3. You say, but there is a plus 3. It comes, but plus 3 is 0. You say, but none of this makes sense. So you can get very easily nonsense. On the other hand is striking how much you can get out of it. And it's striking how it resembles the way we work. There is this book I've studied already another time. It's called Steer Like an Artist by Austin Kleon. And he says that what an artist does, it looks at different types of arts and then reassembles it in such a way that fits with their own taste. And what we do in mathematics is often similar. We see different works, different theories, different ideas, also sometimes from different fields. And then we realize that there are analogies that work when we put them back together, and that's where the new idea comes from, right? We pick from different places, adjust them to fit our language, and then we create something new from it. So there is a lot of this looking around and putting things together, but it feels like there is more than just finding statistical correlations between those things that we see in this reasoning step that goes over. So where you're saying, I understand what the definition of prime number is, and I understand that 9 is not prime. Anyway, before we close the episode, because I see we are getting there, I wanted to ask something about the perception of the subject also from the point of view of students, say high school students or our students, like statistics, and I think also probability, probably because of this confusion that we have, probably because of the many counterintuitive results that come with them, have this aura of being complex, boring theory that is hard, that's something you should steer away from. I was curious to hear from you as the expert then, why do you think, in fact, there is this kind of feeling from the students, and what can we do to show them that you can turn this around and show also the beauty of the interest on the subject? Marco?
So are we speaking now about our mathematics students, or are we speaking about other students that have to take statistics lectures?
It could be in general. I don't think there is a difference between ours and others.
I think there's indeed a very big difference, and I would again say it's somehow complementary. So typically, if I would have to teach a lecture for another institute, for students from another study program, where they do not do a lot of mathematics, then they are very challenged with the mathematics you need for understanding statistics. And typically, they do not get any mathematics courses, but just one compact statistics course where everything is squeezed in. And so one has to rush through the material, and the exam will typically be the most challenging one in their curriculum. Naturally, they don't like the course. On the other hand, for mathematics students, and we have a lot of great mathematics students, of course, they like general mathematics and often feel statistics is a little bit too easy or maybe a little bit too applied. And from their perspective, they have the mathematical understanding and sometimes miss a little bit the deep mathematics in the statistics courses we teach. So it is a completely a different feeling about statistics.
I understand what you say, I agree.
So for pure mathematicians, it's sometimes too applied. For all the others, it's too mathematical.
You somehow sit in the middle between the two now, and then you get penalized by that.
I'm the most unliked person on campus.
Gilles?
I think maybe for some people the difficulty comes from that everybody has an intuition of what randoms mean. But then when you start to set it up mathematically to give definitions and properties, then students can be surprised by actually the heavy setup that you need to really do it, to really study probability rigorously, and how do you formalize these vague ideas. And then there are all these paradoxes that we mentioned that are counterintuitive, that can be a challenge. So I think that there are many students who approach this course of probability theory in first year thinking, oh, it will be easy, and then after some time, Marit nods. So maybe this is not the case. But I have this impression that some students they arrive and at first feel that this is quite intuitive, but then they get lost because they underestimate the investment that they need for it.
Yeah. I would agree that to study statistics and probability theory as a student, it is a completely different type of math. As you already said, it's completely different from general math or most of the applied math courses. And I think that is also where the difficulty comes in for people who do not have a mathematical background or do a mathematical study. Because as you said, Marco, a lot of new information is crammed for them in a subject, and they first need to understand mathematical reasoning and everything that belongs to that. So I think that might be a problem why non-mathematicians have such a hard time with their statistics courses.
Marit, can you give me an honest answer? What did you think about our courses, probability theory and statistics?
My own experience, so maybe I'm not the right person to ask because I first took statistics and then I took probability theory. Well, normally you have the other way around, but that was due. I had some things to finish from my chemistry study, and I found statistics very, very hard, which is logical. I had not taken probability theory beforehand. And it was a course that I needed to put so much time and effort in. But in the end, it was very satisfactory because in the end, I did understand all the IDs and all the main results. And I actually got quite a good grade, which I did not expect when I started the course. And then probability theory was different because I had already taken statistics. So I already knew about random variables and like expectations and stuff like that. So that made it, in that case, easier for me. But I did not think that the course itself was approached by people to be easy. I think that a lot of students see probability theory as a difficult course that is demanding. At least in my experience, it was still demanding, even though I had taken the statistics course already. I don't know, because I only have my own opinion, but I would not say that, as Marco said, that for more theoretical mathematicians, there's not, like, the level is not high enough or it's not hard enough. Like, I personally did not feel that way. I thought they were both very challenging courses in their own way.
May I ask, when you did statistics, was I the teacher?
Yeah. Oh. Yeah. It was during Corona, so that's why you don't recognize my face, since we had online lectures. For me, at least, it was a very challenging course. It was around the time that I didn't have a lot of friends in mathematics, which sounds very sad, but I started mathematics right when Corona came in. So I had only been following one course from the mathematics because I also did a chemistry bachelor. So I had to finish those courses, and then Corona came while I started studying mathematics full-time. So I do not know in this case how people felt about these courses, but that is the effect that they had on me.
And it's, of course, highly recommended to do probability theory first. Yes. Because then statistics really builds on it.
I can definitely see that. But I was a very ambitious student. I wanted to finish my bachelor in 3 years. So then, it's better if you do everything first. I was like, well, I might as well try. It is Corona. I'm in lockdown, so I don't have anything to do. So I spent a lot of time studying statistics.
Very good.
Yeah, it was.
And then you decided against the track?
Well, I was in doubt at first whether I wanted to pursue the probability and statistics track or not. But in the end, I decided that I did like the theoretical mathematics better. But I was in doubt for some time. Yeah,
good
definitely.
To hear.
Yeah.
So you did a good job with your course.
Yeah.
I should have done a little bit better.
Yeah. Like, if I'm thinking about my history, I never had a course in statistics. So we had probability, we had stochastic processes, stochastic differential equations, and that was it, but never statistics per se. And the one thing that I liked from these courses is that life is basically a navigation in uncertainty, and the course's probability is the one that can put this uncertainty in perspective. So even things like the famous problem like Monty Hall or so, I'm not getting into it right now, we are quite late into the episode, but it shows you how much you can misunderstand what you experience because your experience is limited. And one of the first time I actually seen this was because of the probability courses and the exercises that we had there. And I feel like with a statistic course, I would get an even more important perspective on that by actually looking into real data where correlations, misunderstandings, hidden variable play an even more obscure role from the point of the observer.
Maybe even more important is to mention that data typically are noisy. So that you have some measurement errors, and in standard mathematics, you might not take these measurement errors into account. Mm-hmm. You just trust that you have really the functional value, but it's indeed the functional value plus some noise. Yep. And you want to get rid of the noise before you can maybe apply the standard mathematical model for analyzing the data.
Yeah, and I feel that it's a weakness for me. I mean, it would have been good if I had a statistics course in my studies. So from this point of view, I think I would recommend to the students to take those seriously.
You are also welcome in my courses.
Oh, thanks. If I had the time, actually, I would have really liked to come.
Unfortunately, we have run out of time. Thank you, Gilles. Thank you, Marco, for your time and being a guest on our podcast. Thank you, listeners, for listening in again. Thank you, Marcello, for
And thank you to the host.
Yeah, thank you, Marcello, for being here also and making this podcast with me. We hope to see you next time.
And if you like the episode, please share it with your friends and on your social network.
Yes. Can I also add something like...
Yes?
Yeah.
Thank you, Marit. Thank you, Marcello. And I would like to add as a very last comment, hate the statistics, but don't hate the statistician.
If you like this episode, please consider sharing it with your friends and on your social media accounts.